students, my name is Chaitanya, physics faculty at Shakthi International School. Today in this video we are going to learn about an important topic of class 12th chapter electromagnetic induction. Electromagnetic induction. Okay, the topic that we are going to see from this chapter is transformer. And how does this actually work? How does a transformer work? On what basis it is actually working? So now before going any further, let me explain what is electromagnetic induction. We know that according to Faraday's law, okay, Faraday's law states that the induced EMF is equal to rate of change of flux. Okay, so this is the Faraday's law. Faraday's law. In that, this negative sign is indicating it is from the Lenz's law. Okay, it indicates that the direction of current. It helps us to understand the direction of current. Basically, this Faraday's law states whenever there is a current carrying conductor, okay, if there is a conductor, if it is kept in a changing magnetic field, changing magnetic field, an induced EMF will be developed. Induced EMF will be developed. Because of this induced EMF, if the conductor is closed, is closed, okay, closed in the sense circuit is complete, okay, then in a closed circuit only you will have current flowing. Current will be induced current. Induced current will be flowing through it. Flowing through it. What do you mean by induced current? Induced means generated. Generated. Okay. Here also induced EMF means generated EMF. Generated EMF. Now that you know that the current which is actually being generated in anything like in a generator, okay, we are getting it because of rate of change of flux. In general, what is the formula for magnetic flux? If you are writing the general formula for magnetic flux, we know EMF E is equal to minus of d phi by dt. Phi is the magnetic flux we are talking. Phi is nothing but BA cos theta. The number of magnetic field lines passing the unit area of cross section along the area vector or perpendicular to the surface area is what we are calling it as magnetic flux. Now if you are writing EMF, you have to differentiate it with this thing, minus of d by dt of phi. Phi is nothing but BA cos theta. Let's say if it is rotating in that magnetic field, that coil is actually rotating in the magnetic field, then you can write omega is equal to theta by t. From that, theta is equal to omega into t. Substituting that in this condition, minus of d by dt of BA cos omega t. This is what we can write. Now from this, okay, from this we can write EMF E is equal to minus of B into A into differentiating cos omega t will give you omega into minus sine omega t. So these two negative signs cancel, you will get BA omega sine omega t. This is a formula for induced EMF. Or you can write the same as E naught sine omega t. Moreover, this one we are considering that that coil is having only one turn. Okay, let's say if it is having n turns, then the formula of EMF will become n b a omega sine omega t. Okay, so from that case, if you observe, you can write E naught as E naught will be NBA omega. Okay, so that means this EMF is induced in that current carrying coil, in that circular coil or a closed coil, because it is experiencing changing magnetic field. It is kept in a changing magnetic field. Now from this condition you will be understanding that EMF E, which is equal to N B A omega sine omega t. Okay, this EMF E, which is nothing but voltage again, is directly proportional to number of turns. E is directly proportional to magnetic field. E is directly proportional to area of cross section. Okay, and moreover omega also. So all these, let's say if you are taking all those magnetic field, everything is constant. So E is directly proportional to N, where N is number of turns. Number of turns. Okay. Now why we have learned about this? To understand the working principle of transformer. Okay. Transformer, it works on the principle of mutual induction. Mutual induction. Okay. Now if we are taking in this transformer, we are having two coils. One is a primary coil and the second one is a secondary coil. We will be taking a transformer in this shape. This is a core, okay, which is made out of metal. Okay, this is how there will be a core. Now this core is going to be wounded. This core is going to be wounded with primary and secondary turns. Primary and secondary coils. Now this is your primary coil. It is connected to the AC input. This is your AC input. Now there will be another secondary coil which will be connected to the load. Okay, let's say we have connected this one to your load. Okay, this is primary coil, this is secondary coil, this is core. Okay, that is your metal plates. Okay, now this is your metal plates. Now what is happening in this is, whenever there is AC current which is coming from here, it will induce some kind of magnetic field lines. The flux lines will be generated. Now these flux lines, we are going to take these plates to be very hard ferromagnetic substance. Ferromagnetic substance actually absorbs all the magnetic field lines that are actually will be generating. Now these magnetic field lines, they will be allowed to pass through this one. Now when there is a continuous alternating current, magnetic field also will be continuously alternating. That means this secondary coil is actually being placed in the continuously changing magnetic field. That will give you a induced EMF. Okay, let's say EMF in the secondary coil ES is EMF in the primary coil is EP. You can know that it is proportional to the number of coils in the primary, number of turns in the primary, and each secondary will be proportional to number of turns in the secondary. Okay, now basically this EMF is what allows the current to be flowing through it, and this EMF is what allows the current to be coming out of it. I hope you understood how a mutual induction is actually happening between two different coils, okay, because of changing magnetic field that they are being kept in. Now there are two types of transformers. One is a step up transformer and there is a step down transformer. In a step up transformer, the main function of it is to increase output voltage. And in the step down transformer, the main function of it is to decrease output voltage. That means here E primary will be lesser than E secondary. In this, E primary should be greater than E secondary. So we are stepping down, we are decreasing the output voltage. In general, you can write from this EP by ES is equal to NP by NS. Since induced EMF is actually being depending on the number of turns. From where we got this formula? We got this formula from E is equal to N B A omega sine omega t. Okay, since the frequency is same, both the cases frequency will be same, area of cross sections will be same. Since it is a ferromagnetic substance being used, magnetic field also will be same. So E is directly proportional to N. So EP by ES can be written as NP by NS from that. Now, if you want step up, okay, in this condition, since E is directly proportional to number of turns, NP will be maintained. NP will be maintained at less number compared to that of NS. Number of turns in the secondary coil will be greater than number of turns in primary. So that increased output voltage will be coming. In the same way, number of primary turns will be greater than number of secondary turns in the step down. Okay, so you will decrease the number of turns in the secondary coil so that the voltage output is becoming less. Now, if you are talking about power, for an ideal transformer, for an ideal transformer, power input will always be equal to power output, making that power is nothing but EMF in the primary coil into current in the primary coil should be equal to EMF in the secondary coil into current in the secondary coil. So you can write EP by ES is equal to IS divided by IP. Now using this formula we can write which is equal to NP divided by NS. So we are having a relation with the currents also. The power is maintained constant. So now if you are understanding the efficiency of ideal transformer, efficiency of ideal transformer, it will be equal to 100% because power input will always be equal to power output. But for general transformers, general transformer or a real transformer, okay, efficiency can be written as power output divided by power input into 100. Okay, so this is what we can write as a general formula. Power output can be ep uh, es into is divided by ep into ip into 100. That is what we can write in this condition. Okay, so this is how the transformer actually works. Basing on the principle of mutual induction, we can create a step up transformer or a step down transformer by just changing the number of turns in the number of turns of the coil that we are using. Okay, thank you. We'll meet in the next video.